Greetings and welcome, friends. We're taking a look at page 160. We're talking about equations of parallel and perpendicular lines. Specifically, in this homework assignment, we were talking about perpendicular lines. Right, Alyssa? That's right, Mr. Waddy. So here it says, write an equation of the line passing through point P that is perpendicular to the given line. Graph the equations and check to see that they are perpendicular. So I've got a point. I've got a line that my line will be perpendicular to, bless you. And then I've got to find the equation of my own line. Now, I don't know if you recognize this. Watch this. I'm going to give you a little shortcut here. This is of the form y minus, y1? Yeah, we could use k and h. Y minus y1 equals m parentheses x minus x1. I don't know if you guys have ever seen this one. You recognize this? Recognize this? This is point slope form. Anybody? No? Yeah, back in the day. So if I look at that, that would suggest to me that my sloppy slope is just the -2. All right, so the slope of the line they gave me is -2. So my slope is if their slope is -2, what's my slope if mine is perpendicular? +1/2. Flip it and change the sign. Okay, you could have distributed, you could have added 4 to both sides, put that into slope-intercept form, and that would have been great. But I just wanted to point out we had a little bit of a shortcut because this was in a form that was valuable to us. Let's see, this we'll call x1 and y1 for the coordinates of that point. So what I'm going to do is plug in, I guess I might as well write that form as well, right? In the form y equals mx plus b. Let's plug in what we know and solve for what we don't. Right? Alyssa, you following along? All right. So let's see. Plug in 3 for y. Yep. A half for m and 2 for x. Oh, how convenient. That m and that x. And plus b, I do not yet know plus b. So we'll solve for b. So I'll get 3 equals half of 2 is 1 plus b. Subtract 1 from both sides. And I will get b equals 2. Actually, I'll even write that in my, I'll try to color coordinate with my thoughts from the other day, right? I think I wrote the y-intercepts in red. So if I want to now graph this, or well, okay, let me write the equation first. So this is going to be y equals 1/2 x plus 2 when I plug in just the slope and the y-intercept. I'm going to keep this out of it for now. That point will make this equation true, but I want to write this generically so all possible equations would work out. Yeah. Let's see. So for point slope form for this first line, let me just make a little side note here. I guess I should use a different color here. I don't know. This line happens to pass through the point -3, 4 and has a slope of -2. If you put that in slope-intercept form, you also would have been able to get that information just fine. Let me All right, you with me, guys? Are you with me? Here we go. So, I'm trying to think of where these lines are. So 1/2 x plus 2 and -3 up 4 slope. Okay, yeah, I think I can just kind of put my grid right in the middle for this one. I'm just trying to plan ahead, you know, where my axes land. That's usually a good idea, just to plan it ahead. So you guys graphed this obviously last night, right? You guys are expert graphers. Oh, I think most of the I think they're on the test. Yeah. Let's see. So actually, I think I might even just on the test most of the time have you go this far. To be honest, I don't think I was having you graph in the examples that I had show up. So let's see. Let's graph this first line. So the point was -3, 4. So a 1, a 2, a 3 to the left, and up 4. Here's a point from my point slop form, and then the slope was -2. So down 2 over 1, down 2 over 1, down 2 over 1, like so. Let me see if I can draw this line real quick. Something like that. All right, so that was the first line. The second line, my new one, I'll graph in purple, has a y-intercept at 2 right here and a slope of 1/2. So up 1 over 2, up 1 over 2. I also could think of 1/2 as being equivalent to -1 over -2. So notice this, I could go down 1, backwards 2, down 1, backwards 2, like so. And if I draw that line, something like that. And that looks pretty perpendicular to me, and we know that it's perpendicular because the slopes happen to be opposite reciprocals, and that works out. Even though this point of intersection is at a weird spot, I know that it still works out. All right, let's quickly. All right, here's the problem everyone's thinking of. How do I find the distance from point A to the given line? All right. I didn't? Oh, no, he didn't. What? Let's see. Oh, you're right. Good call. All right, let's see if I can do a live recovery of this. All right, 22, you're thinking? All right. That would be more valuable to you. Thank you for pointing that out. I was trying to pick a challenging problem here, but I guess I went more challenging than I assigned. Uh-oh. There we go. That looks like a thing. Bam. Da-da-da-da. Problem solved. Let's see. So what do I need to do to find the distance from a point to the given line? The point is going to meet that line perpendicular. So I'm going to first find equation of line perpendicular to given and through point. All right, step 1. Step 2, I will find intersection between my new line. No, yeah. So find the intersection between the two lines. All right, that one's usually solved by substitution, is the easiest way. And then the intersection will be a point. I have a point. Using those 2 points, I will, let's see, step 3, find the distance between those points. And I'll just pretend that's the word between. All right, and that would be done using the distance formula. All right. So let's. So now that I've kind of outlined my procedure, just because I don't want us to get lost in the fray, let's figure this out. So I've got to find the point, the line perpendicular to the equation through the point. The slope of their line is 1. So the slope of my line, Malik, is also 1. Right? Makes sense. Their line slope is 1. Oh, I lied. My line slope is -1 because the reciprocal of 1 is 1 and the opposite of 1 is -1. All right, so let's see. So let's plug this in to slope-intercept form and solve for b. So I'll have -3 is equal to -1 parentheses -9 plus b. Not unlike the problem I just went over. -3 is equal to +9 plus b. Subtract 9 from both sides. And I will get b is equal to -12. So between my slope and y-intercept, I now have the equation of my line. Y equals negative. You could write -1x. I'll just write -x minus 12 is the equation of a line perpendicular to the given one that passes through the point. So now I want to find the intersection between those two lines. So I've got y equals x minus 6 and y equals negative x minus 12. To find the intersection, we will use, I don't know, substitution perhaps. Check this out. If this is equal to y, that's what it's claiming, then I can exchange it for y at any point during this problem. So I will substitute, I will replace that for y. So let's see, so x minus 6 equals the opposite of x minus 12. Let's solve for x, bring those x's together, add it to both sides. 1x plus 1x, 1 apple plus 1 apple is 2 apples, my friend. 2x minus 6 equals negative 12. Guys, we are on a roll here. We're going to do this problem. It's going to be amazing. Add 6 to both sides. I get 2x equals negative 6. Divide both sides by 2. Right? And I will get x equals negative 3. Now, that is not the intersection. That is a single coordinate of the intersection. But if this is equal to negative 3, watch this. I'm going to plug this in up here, and I can solve for y. Right? So y is going to equal negative 3 minus 6. Y is going to equal negative 9. So that means my ordered pair is negative 3 comma negative 9. So I'm going to find the distance between negative 3 and negative 9. And what was the starting point? It was negative 9, negative 3. Those seem like symmetric almost or something. All right. So if this point was x1, actually, let's see, x1, y1. If this point was x2, y2, let's plug it into the distance formula, which you guys all have memorized. So the distance is equal to the square root of, let's do negative 9 minus negative 3 squared plus negative 3 minus negative 9 squared. Let's be careful here. Don't let it fool you. Negative 9 plus 3 is negative 6 squared. Plus negative 3 plus 9, that double negative becomes a plus, will be positive 6 squared. It looks like this is going to be root 36 plus 36. So square root of 72 is the distance. 72, what is the largest perfect square that goes into 72? Looks like 4. And no, 36. Classic, 36. I could have reduced this radical into 36 times 2. You guys remember how to reduce radicals? Square root of 36 is 6. So 6 rad 2 is the exact distance. If I want an approximated distance, 6 times the square root of 2 is approximately 8.49. Actually, tell you what, we're accelerated, folks. Let's call this 4853. We'll go out to 4 decimal places. But right there's the exact value. And this would be measured in units. And that is the distance between those 2 points, which happens to be the distance between the point and the line, which is measured perpendicular to the line because that will be the shortest distance. Let's see. Do I have time for this one? 44. Let's see. 233. Yeah, let's do it. Okay. All right. It says the line through those points is perpendicular to the line y equals x minus 28 sevenths. Question: what is the slope of this line? 1. So the slope of our line is going to be the opposite reciprocal, which is negative 1. Okay? Here I know that it passes through those 2 points, which tells me I know that the slope between those 2 points will equal negative 1. What's the slope formula, you might ask? Well, m is equal to y2 minus y1 over x2 minus x1. Let's plug in this for slope. Let's plug in this for x1, y1, and x2, y2. Plug in what we know and solve for what we don't. The most classic of algebra problems. Let's see. So y2 is 0 minus y1 is 2 divided by x2 is 7 minus k. Actually, it would. You know what? It would have been easier to flip these around so my k was positive, but we'll live with it. We'll live with it. Equals the slope, which is -1. So I've just plugged in for all of these things and plugged in -1 for m. And let's keep going here. So I want to solve for k. This is interesting. Dealing with a variable in a denominator. Let's cross multiply. Do you guys remember cross multiplication? Are you guys familiar with the idea? So this will be -1 parentheses 7 minus k is equal to, I guess it could simplify that to just -2 times 1. I cross multiplied. You guys remember that? No? Maybe? Basically, what was it? If a over b equals c over d, it was even a conditional statement, then AD is equal to BC. Cross multiplication. All right, so notice my variable is no longer in the debottominator, as sometimes I call it. Let's distribute this -1, and I will get -7 plus k. Hey, my k became positive after all. And then I would solve by adding 8 to both sides. And it looks like I get k is equal to 6. K, almost there. K equals 6. To solve for k. Oh, with the save, thank you. I don't even know. No one knows where that came from. It's 7 to both sides. That's even better. Yeah, where did that come from? 7 minus 2 is 5. All right. So I was able to find the value of k that made that true. That means the line passes through 5, 2 and 7, 0. And that would be the line that has that slope. Question, comment, observation, Malik? No, that's why I was hesitating whether or not to give it to you, to go over it right now. But it was still interesting. It pulled in some concepts. It pulled in the idea of plugging in what we know and solving for what we don't. Pulled in the idea of perpendicularity with their slopes being the opposite reciprocals. That idea shows up on the test. All right, so thanks for watching, internet friends, and best of luck to you for your internet test. Have a good day.